Hello, everybody. Welcome to the Critical Issues Forum Online Teachers Workshop. So now we would like to start our first lecture. The title of the lecture is Why You Should Be Worried About the Bomb and What You Can Do About It. The lecture will be given by Mr. Jean Preez. So now, microphone is yours, John.
Thank you, Masako. It's my pleasure to give the first lecture in this series, and I hope you find this useful in engaging your students in preparing for the Spring 2020 conference. As mentioned earlier, the title of the conference is the purpose of the conference is to instill critical thinking among students about their future and a future free of nuclear weapons and what they can do to get rid of these weapons and to live in a nuclear weapon-free world. The purpose of this lecture is to give you an overview of the threat of nuclear weapons, why you should be worried and why your students should be worried about the bomb, and what can you and they do about it. During the lecture series, in addition to this one, we will have more detail on some of the aspects that I'll cover in this talk. You'll get more lectures on the treaties and mechanisms that have been in place to prevent nuclear weapons. You will get more lectures on the scientific and technical aspects of it. The purpose of this talk is just to give you an overview. The slide starts with a comical reflection of two world leaders, Kim Jong-un on the left and President Trump on the right, riding a nuclear bomb. Of course, if you are old enough and remember the movie that was made many years ago, Dr. Strangelove, you will know the reference to riding a nuclear bomb, because that's how the film ended. I will, at the end of the slide presentation, also provide you with a few slides on assignments that you may wish to use in your classrooms. These assignments are specifically designed to focus the attention of students on the threat of nuclear weapons and exercises for them to start thinking critically about what they can do to prevent this threat. The very first nuclear weapon or nuclear device was detonated in the Almagora Desert in New Mexico in July of 1945, the so-called Trinity device. That is the big fireball that you see on the left. The father of the nuclear weapon, Dr. Robert Oppenheimer, who led the Manhattan Project in the United States, when he saw the explosion, the words of the Bhagavad Gita, the Hindu scripture, came to mind. If the radiance of 1,000 suns were to burst at once into the sky, that would be like the splendor of the mighty one. Now I am become death, the destroyer of worlds. These are very prophetic words. And if you think about the power of nuclear weapons, you can imagine what went through the man's mind. He later became quite opposed to nuclear weapons once he realized how they were being used. The image on the right, the plume that you see, is the plume taken from the Enola Gay, the B-29 US bomber that dropped the bomb on Hiroshima. And what you see below is the destruction that that bomb caused, decimating the city and causing thousands and thousands of deaths, not only at the time of explosion, but also many, many years later. This image is our beautiful Earth. This was taken from Apollo 10 in 1969 and from 26,000 nautical miles on its way to the moon. And we can see the clouds, we can see most of central Northern America and parts of South America, and it is associated very, very often, this particular picture, just to show the beauty of planet Earth. The following picture shows planet Earth, what it would look like after a large-scale nuclear holocaust or a nuclear exchange of weapons. It has been artificially darkened in the Northern Hemisphere because that's where most of the weapons are located. It is believed that an exchange of nuclear weapons between Russia and the United States, or in the past between the Soviet Union and the United States, and also supported by the US allies, US, France, and the UK, and then of course China will be involved as well, and so would India and Pakistan likely. This would lead to a nuclear winter, blanketing the Northern Hemisphere and eventually the Earth, which will lead to the death and destruction of not only billions of people, but most of the infrastructure and livelihood that we as human species enjoy. A famous Indian novelist and political activist, Arundhati Roy, made these comments: "The nuclear bomb is the most undemocratic, anti-human, and outright evil thing that man has ever made." She reflected that this world of ours is 4,600 million years old. It could end in an afternoon. So on the left is a picture taken from the moon towards Earth. The image of Earth that you just saw was darkened out. So this is what, again, it's symbolic, what Earth could look like a day after a full-on nuclear exchange. The Bulletin of Atomic Scientists in 1947, just after the end of the Second World War, came up with a rather ingenious way to emphasize the dangers that the world are in. And they used the symbolic doomsday scenario. The doomsday clock being at midnight on doomsday, the world will destroy itself. Now you can imagine what the world was like just after the Second World War. At that point, they considered that the world is 7 minutes to midnight. 7 minutes is not a long time, but given the time frame, they've considered that to be appropriate. In February of 2002, just prior to the US invasion of Iraq, that started also of course, the war in Afghanistan, the scientists moved the clock back to the same setting as it was in 1947. Now, you may recall that those days there were a lot of tension, and of course those wars continue, but there was a lot of destruction and a lot of deaths, Americans and people from Iraq and Afghanistan, and many other countries died in those conflicts. So that was a really tough time. Just recently, in January this year, the doomsday clock was moved to 2 minutes to midnight. Given the estimate by the Bulletin of Atomic Scientists, and these are some of the world's top experts in this field, about the looming threats of nuclear war and climate change, combined, these two are probably the biggest threats that planet Earth have faced. The question is, and a question that you can ask your students, where will the clock move to in January 2020? Nuclear weapons are unique. They have, as a single weapon, more destructive power than all weapons used in all wars through human history. Towards the end of the talk, I will show you, will give you some advice on how to use an experiment in your classroom that you can actually show this. Quickly to go over the pictures. You'll see in the top the numbers and the destruction caused, the numbers of death and destruction caused by the bombs dropped on Hiroshima and Nagasaki. And those were the immediate deaths. Many people died of radiation years later, or were also disformed years later. Other than the comical caricature of Kim Jong-il, Kim Jong-un's father on the left, flying over Honolulu, in those days, and I'm using the term axis of evil, President Bush the first, or President Bush the second, I beg your pardon, named a number of countries as part of the axis of evil. Iran and North Korea were part of that. However, the picture right in the middle is a US intercontinental ballistic missile being equipped with multi-entry vehicles, MIRVs. These are multiple warheads on one missile. Each of those warheads could be in anything between the range of 150 to 300 kilotons. That is 1,000 tons of TNT is 1 kiloton. Now, if you compare to the pictures on top, Hiroshima, the bomb that was dropped on Hiroshima was about 15 kilotons, and on Nagasaki, close to 20. Now, can you imagine the destructive power that such a missile with so many warheads on it can do? So the question is, what is the true axis of evil? The people or the weapons? The little weapon in the middle was called the Davy Crockett. It was the smallest nuclear weapon ever made. It was fired from a bazooka device. It was never used, but it was designed to be used in battlefield conditions. On the right, you'll see a missile launcher or a missile delivery system. That's India. So the weapons are no longer just in the possession of major powers. India is a rising power and has quite a large arsenal. So does Pakistan and a number of other countries. Some horrific pictures on the below left, the aftermath of Hiroshima, a child that is absolutely burned to death. And then in the middle is the largest bomb ever made, the Char bomb. It was never detonated, that was detonated as a test, about half of that size, but that was designed to be 100 million tons of TNT. There's some fears that bombs can even be made to fit in a suitcase. Bombs can be used, make small bombs to penetrate deep under the earth. And then on the bottom right is a picture of the Security Council during the Cuban Missile Crisis, when the Soviet Union placed missiles in Cuba, and it was feared that that could have led to a full-scale nuclear war between the two countries. This picture just shows, and I'm not going to go into all the detail, you'll get a far more detailed talk on this, where the nuclear weapons are. Today, and this is 2018 estimates, about 15,000 nuclear warheads are in the arsenals of 9 countries. Why do they want them? Of course, the United States originally was fearful that Hitler and the Nazis may acquire nuclear weapons, and there was evidence that German scientists were working on a program. They also wanted to end the war with Japan, which they did, but at the same time, they wanted to deter the Soviet Union. The question is, why do they want nuclear weapons today? Of course, nuclear deterrence is a very, very important factor. And so if you go through the list, you'll find each country has a different reason why it acquired nuclear weapons, similar to the United States, or even other reasons. For instance, in India's case, it had a lot to do with prestige. Pakistan's case to rival India, North Korea to originally deter an attack by the United States. Iraq had a program of nuclear weapons. They were concerned about Iran and a variety of other factors. So this is also very useful to have a discussion in your class. And why do you think, or why students think countries need nuclear weapons? Very, very briefly, nuclear weapons are very difficult to make. They need a key ingredient, and that is called fissile material. Now, fissile material is, basic fissile material is uranium. Uranium that is mined cannot make a nuclear weapon. But uranium that's mined and that is enriched through what is called the nuclear fuel cycle, through various processes that include chemical processes, but also a process that uranium gas is pumped through what is called centrifuges, and these centrifuges eventually produce enriched uranium, and enriched uranium to a point of about 90% is used for nuclear weapons. Plutonium, on the other hand, is not a natural product. It comes from reprocessing. When the uranium fuel is spent, it's taken out of the reactors, and then the plutonium can be extracted from that. Now, plutonium-239 and uranium-235 are ingredients of nuclear weapons, either by themselves, as they were in the case of Nagasaki and Hiroshima, but combined in modern-day nuclear weapons. Nuclear weapons cost a lot of money. In 1998, it was estimated that the US nuclear program alone cost about $5.8 trillion up to that point. The Brookings Institute, a very famous institute in Washington, D.C., estimated that 5.8 trillion, if you take that in $1 bills and you put all these dollar bills on top of each other, then those would reach from the Earth to the moon and nearly back again, a distance of 459,000 miles. The projected cost over the next 30 years, as of 2017 to 2047, is $1.7 trillion. Can you imagine, you as teachers, what you can do with that kind of money in educating tomorrow's leaders? Lots of types of nuclear weapons, from very basic weapons that were used in the Second World War to so-called boosted and fission weapons. You'll get a lecture on this from my colleague, Dr. Ferenc Delnocki. I will not spend too much time on it. But weapons are useless if they cannot be delivered. And so there's differences in the types of weapons, whether they are strategic. These are weapons typically based on intercontinental ballistic missiles, or submarines launch ballistic missiles. As you see, there are pictures of submarines that carry these missiles. To tactical nuclear weapons, they can be carried on aircraft. They can be launched from a variety of platforms. They are typically more designed to target specific targets as opposed to destroying cities. There's also fear of improvised nuclear devices that terrorists, for instance, could get hold of or design to create fear in cities. So nuclear weapons have different yields. So the typical conventional bomb that uses TNT or another chemical-based explosive is about 1,000 pounds of TNT. That's a very large conventional bomb. So again, if you think about Hiroshima and Nagasaki, then we're talking about 13,000 tons and 20,000 tons. In today's typical nuclear arsenal in the United States, and similar to that of Russia and other countries, they range between 100 to 300 kilotons, or 100,000 to 300,000 tons of explosive power. Today, there's a brand new weapon that the United States is producing, and it will be entered into U.S. arsenal soon. And this is this one here. It is a low-yield weapon. It's designed to be detonated at a variety of yields, and it can be predetermined before the weapon is launched, between 5 or 5,000 kilotons, or even as high as 50,000 kilotons. Very, very dangerous weapon. And Russia has been developing a supersonic torpedo to be launched from a submarine. Now, submarines typically launch submarine ballistic missiles launched from a submarine, and they go into lower space and reach their target by coming back into the atmosphere. The supersonic torpedo, however, is launched just like a normal torpedo and travels underwater towards its target. And for instance, you can target San Francisco, you can target Miami, you can target any of the coastal cities around the world with such a weapon, and will cause the same kind of destruction than a weapon that is launched from a ballistic missile. Nuclear weapon effects. There are different kinds of effects. There's the effect that is caused by the overpressure, 5 pounds per square inch. You may not think that is a lot if you think about what pressure you need to put in your bicycle's tires or in your car tires, but 5 pressure for PSI released by a weapon in a large and very, very fast way can blow down a house. And you can see from the figures, this is what happened with a relatively small nuclear weapon in the case of Hiroshima. Then the weapon also ignites firestorms. This is ignited by thermal radiation. It burns for a very long time. Of course, hot gases ascend rapidly, and it burns the air at a pace of about 100 miles an hour. The heat inside the firestorm is 2,000 to 3,000 degrees Celsius. And of course, it sucks out oxygen, and so a lot of people, even underground, will be killed, not only through the heat, but because the oxygen is sucked out. Thermal radiation. This is normally the aftermath of a nuclear attack. It's proportional to the size of the weapon, of course, and it also depends on the distance, how far you're away from the explosion, what weather conditions are in place, and what kind of surfaces. Some surfaces would absorb radiations, others would not. This causes some immediate effects, but in many cases, not only as a result of those weapons dropped in Hiroshima and Nagasaki, but also weapons that were tested. More than 2,000 weapons have been tested over the years, and these cause long-range damage on humans and animals. Thermal radiation attenuates slowly, and they also cause retinal burns, causing obviously blindness. If you want to have your students play around with an interesting online tool, nukemap.com offers a tool where you can fill in on the side which city, and you can also decide what size of weapon, and you can also find what kind of weapon is used, and you'll see if you play around with it that there's a variety of types. And then you can fill out whether the weapon is airbursted, that means does it explode above ground or on the surface, and you can determine how many casualties. Now this is a little bit apocalyptic, but it shows the effect. So this is San Francisco, a 300 kiloton weapon that is typically on a intercontinental ballistic missile, and you can see the whole of San Francisco, the whole city will be destroyed by one single weapon. And the impact will even be, much, much farther from there. So the fireball will be even outside the city's range, and the thermal radiation will go as far as 7 kilometers away. So before taking a break, I think it's good to reflect. And again, this is a cartoon, but we are talking about educating our children. And the question always comes up, what do you want to do when you grow up? This young boy says to his dad, alive if it's not too much trouble for you. So this is a very crude way of looking at the future, but I think it may also resonate to your students. It brings a bit of a smile to people's face, even about despite the nature of the topic that we're talking about. Okay, we're going to take a quick break and we'll get back with the rest of the talk.